Hello, I'm Jim Tobul, and I have my 1945 Chancevot F4U-4 Corsair, and I'd like to share it with you today and tell you some interesting facts about the aircraft. The aircraft is an awesome plane. I'm flying here at AirVenture pretty much all week. I fly Navy Legacy, and I'll be flying with the F-35 Charlie model and also the Growlers, which is an F-18 platform. But let's talk about the Corsair today. This is a magnificent airplane. It was designed back in the late 30s, early 40s. So the guys that designed this airplane were using slide rules. It's unbelievable the technology we had at that time, or the lack thereof. And then designing this from a clean sheet of paper did not exist. So they had the largest propeller and engine combination at the time and built the aircraft around the engine and propeller. The propeller at the time was built from aluminum. It has a little bit of a hollow center. It is 14 feet in diameter, and it was the largest propeller at the time. Coupled with the Pratt & Whitney R2800 engine, this one is a little bit modified for me because I do a little air racing, I do formation, and I do a full aerobatic acro routine with the airplane. So I want the horsepower and the speed to do that with. In designing the aircraft, they use this propeller and engine combination, and then they had to design the aircraft. Being that it's a 14-foot propeller, this is a very difficult challenge in that the propeller became very close to the ground. So the original design had a straight wing coming across. And having the straight wing, the gear was so long that it would never survive carrier operations. So the engineers had to decide what to do. So one of the engineers decided, well, if we put a gull in the wing, it will shorten the length of the gear, and it should be able to handle carrier operations. Well, they were spot on. Got their little slide rules back out, and figured out, okay, we have to redesign. Awesome. The gull, I get a lot of questions about, well, does it enhance? What does it do from the flight characteristics? It's not a plus, it's not a minus, it's just a gull wing. So it looks cool, and it's a very unique design. You can always tell a Corsair because of its gull wing. So that's really a cool factor. So going back to the engine, this is a later version. They made earlier Corsairs with just a round nose bowl. In the Dash 4, they added the propeller blade, so we have 4. This is a chin scoop, they call it, and this is the air scoop for the carburetor. So it goes from here straight in the carb. The earlier versions had little cheeks tucked inside, and they weren't very efficient. This is a great, very highly effective airflow straight to the carburetor in almost a ram air effect. So it's very efficient and very effective. Coming around the outside of the nose bowl, this is an interesting fact. A lot of people don't know about this, but there's a little spring load. I don't think, oh, look at that, it still works. It has a spring load, and what you do is you have a platform. This is for the maintenance guys. And so you would take and plug in a rod which has a step platform. The mating surface is in right here, and the other end of the maintenance platform would go into here, popped into here, and now you have a platform in which you can work on the cylinders. The Pratt & Whitney R2800 has 18 cylinders, 36 spark plugs, just to throw that in there. So there was a lot of maintenance, and when the mechanics had to work on it, they could work on the engine from the lower side without a maintenance platform. But you're out in the Pacific Islands. You're out in an island. You don't have access to a lot of ladders. So this became a platform for the mechanics to repair the engine, work on it, and service it. Because you got to remember, there could be 30 Corsairs. You're not going to have 30 or 40 or 60 ladders hanging around. So this was a great design and very unique, and a lot of people don't know about that. So as we transition, we see cowl flaps. And the whole reason for cowl flap is for engine cylinder cooling. I have a limitation. I have a cold side and a hot side for the cylinders, and I can adjust those cowl flaps to keep me in the green range on the cylinder. So in high power, when I'm taking off, they have to be wide open. I want as much airflow over those cylinders because they are at their highest performance. And then as I climb and I level out, I close them up because now I have a lot of speed, and that's enough airflow with the reduced power to keep me in the green range for the cylinder temperature. So those are very, very important. And this is unique. This door opens up and there's a tank inside. Now, I don't have the tank, but this engine has what they call military power. Throttle goes up and stops, and there's a stop up there that has a copper wire. And you can fly this aircraft up to the copper wire. If you break the copper wire and go up, this is water injection. And because the engine is already at max performance, when you break the wire and you induce or inject water into the engine at its highest level, the water makes the engine explode, and you will get another almost 100 horsepower if you need it. So if you're in a bad situation, you're against the enemy, you can go ahead and break that wire and that's where you fill that tank. Now, I don't have the tank in there. Some guys use them for racing where they can take ADI, and there's all kinds of things you can do, but that's a door that a lot of people don't realize what that's for. So that's water injection. And by the way, when you break that wire, the maintenance officer, crew, whatever, gets inside and sees the break in the copper wire, engine comes off. That's it for the engine. You get a new engine. See, it's a one-time use. That's an interesting fact, huh? So, as we transition, I don't know if you can see this, but there's a little door up there. Do you see that little door right there? Yes. It has a little screw on it. That, holy cow, I don't know if you can see this, but there's a mating hole in the wing. Let's go over here. I'll show you this real quick. There's a mating hole right there, and that hole is threaded. And inside there is threads. And so when you fold the wing up, a jury strut goes in there. And you thread the jury strut into the wing, and you thread it into the motor mount. That's actually a threaded hole in the motor mount. And the jury strut keeps the wing in lock position when it is on the carrier, going through a storm. If I had the wings up and there's going to be high winds, then I would put in my jury struts. That's an interesting fact. So at any rate, that is for the jury strut. It's, again, a lot of people don't realize what that little door is for. So as we transition, we look inside the wing root. And inside the wing root, we see these diverters, air diverters right there. Those air diverters on this side is called an intercooler. On the original engine that was in this aircraft, it had a supercharger, and it required a lot of cooling. And these intercoolers kept that supercharged section of the engine cool. Again, that was a Dash 8 engine and some of the early versions. That engine required 450 horsepower to move all the clutches and all the mechanism. It added almost 3 feet in length to the engine. Very early design of the R2800. I have more of a higher, I'll just say a newer engine, and mine's electric. So actually I gained 450 horsepower of usable horsepower on this engine to fly with because of the lack of all the clutches, and this intercooler is not connected. I took everything out because it's no longer needed on the engine that I operate. It's a cargo engine, very reliable, very strong, and my horsepower is a lot bigger than most, and I like that. But this is for the intercooler, which I don't have, and I had put baffles in here to limit the amount of airflow, otherwise it'd want to pop my cowling out. So that's a lack. These are oil coolers, and I have one on each side, and this is to cool the oil. Now in combat, you know, you can get shot. That's another thing. I took it all off, but there was armament. There was armor plates all around this section to protect the oil cooler from enemy fire. And so small arm fire could hit it, it just bounce right off the armament plate. So it protects this, because this protection of this oil cooler was really important. So if a round would come in this direction and take out that oil cooler, and you see it streaming out the back, in the cockpit, I can isolate this cooler and operate off the good one and still continue to fly, and that cooler has enough efficiency to cool the oil for the engine, and I can make it back to the boat. So there's a lot of systems that were doubled up on for redundancy and wartime effort. So after the wing root, what we have right underneath is one of the pylons. This aircraft has 2 pylons, and they're multi-purpose, multi-function. Number 1, they can handle drop tanks, 150 gallons each, and they have 2 drop tanks will carry 300 gallons of external fuel on top of 234 internal. So you have a total of 534 gallons of total usable fuel, which goes beyond my limit as a pilot. I'm 5.5 hours and I'm done. I'm coming down. I want a Coke. I want a pack of crackers. I'm done. I went from Colorado Springs to South Carolina, Charleston, South Carolina, landed at 5.5 hours, and I had 100 and some odd gallons left in the airplane. That was nonstop. Too much for me. But the aircraft has that. In Korea, this aircraft has over 200 combat missions in Korea on the USS Boxer, the Valley Forge, and the Oriskany aircraft carriers. A normal load would be the right drop is on the right pylon. The left one would have a 500-pounder bomb, droppable bomb, or a 1,000-pound tiny TIM. That was a very common load. On top of that, we would have, this aircraft has 6 50 caliber machine guns with 2,400 rounds of ammunition. Also, it has 4 rocket rails on each wing, so you have 8 5-inch HVAR, that's high velocity aircraft rockets, on this aircraft. So you had the bomb, the drop tank, 6 50 caliber machine guns, 8 5-inch rockets. This aircraft had a tremendous firepower in Korea. It was a close air support. They'd call them in, and it would be Corsair after Corsair just unloading a tremendous amount of firepower, and these were very popular. I had a lot of, I'll say, ground pounders, you know, Marines, whoever they are, said, this aircraft saved my life, because they came in and supported us ground guys, where the Air Force was way up there somewhere dropping whatever. So the aircraft really had a huge impact in the Korean War. So we have the drop tanks. Now, if you can look up underneath here, that's a hook, and we have one on each side, and that is a catapult. And they would hook up the cables and shoot this plane off the deck of the carrier, if need be. Some of the Jeep carriers had a little shorter deck, and they need a little extra oomph. But they found out if they turn the carrier into the wind, got about 25, 30 knots into the wind, the Corsair didn't need it. It could take off under its own power, off the deck, fly off without using the cat shot. So that was interesting. A lot of guys, some of the guys don't have those hooks on their aircraft, so that is a rare item. Okay, and as we progress to the gear, what we have is another challenge from the engineers at Chance Vought. They can't just roll the tire, just when the gear goes backwards, it can't stay in this orientation. The wing is not that fat. So what they have to do is turn the wheel 90 degrees through a knuckle arrangement on the inside so that it goes up into the wheel well flat. It's a very unique design that the engineers had to design a solution, and you can see that wheel well is very tight. And everything fits in there very, very tightly and nicely. And I have to be careful on my tires, because if they're just a little too big, they will drag inside. Another interesting fact, back there in the back, you see that piece of board, that piece of wood back there? That wood has grease on it. And in case this cable, which collapses, this gear extends about 1.5 feet. This cable, when the gear is going backwards, this cable collapses the gear and gets tucked into the well. If that cable breaks for whatever reason, the tire is going against that wedged piece of wood and it will slip. So I can put the gear down, it's wedged, I wiggle, pull some G's, and it will slide right off that piece of wood and come back down to where I can land. So that's an interesting design piece that Chad Spot did, is put a piece of wood in the grease. It works like a champ. Let's talk about the brake system. This particular brake system I modified. The original was a Goodyear aircraft brake, and it was metal on metal. It had a bronze disc, had stators and rotors, and it's very challenging to get replacement parts. So I replaced them with a red line variant, which has more common pucks. It acts as more of a common disc brake. The effectiveness is close to the original, not quite there, but at least it's easily repaired with common parts that are readily available out there. So I did modify that just for the longevity. I fly the airplane a lot and I do go through brakes. So that has been modified from the original. The wheels, notice the bolts on the inside. Those are split rim wheels. And if I go to replace the tire, I simply just take the nuts and bolts apart and the two halves come apart, and I replace the tire and tube and then bolt it back together. The original design was a solid wheel. And by the way, they're magnesium, not aluminum. So it's really interesting how much magnesium they used on the aircraft. But the solid ones are extremely difficult to buy. Fine tires, but more so putting the tire bead around that lip. Very difficult. So this was an enhancement with the split rims, and obviously that's what I use. This is what they call an LSO light. A lot of guys say, oh, that's where your camera is. Not so. This is LSO, and that has a red, green, and yellow lens. And so the LSO officer is watching your aircraft coming in to land on the aircraft carrier, the boat as they call it. And your AOA, that's angle of attack, gives you a relative airspeed. So as you're coming at the boat, if you were too fast, your nose would be low, and you would have too fast of a light. You would have, you know, obviously the upper one is yellow. It's saying yellow's too fast. Well, as you slow the aircraft down, which the LSO, the guy with the flags on the ship, telling you to slow down, as you slow down, the AOA, the angle of attack, changes. Green is right in the center. The LSO is looking for this green light to know that you are on the right speed. Your right speed, right altitude. And he's going to look when you're too high of the glide slope or too low. And if you get too slow, the AOA pitches up, and then he sees the red light and says speed up, because you're too slow. So there's an exact speed that he's looking for, and this is what's telling him how fast this aircraft is going. Very unique. And I still have it, and you know what, I think there's a light bulb in there, and I think it would actually work too. It turns on in the cockpit for the landing phase only, and then you turn it back off. So that's kind of cool. This is where 3 50 caliber machine guns go. This is my spare set of wings. These are metallized. The original wings that I have fabric interlaced. I do have the 50 caliber machine guns in there, and you would see that they're staggered, and I'll show you on the backside why. But that's where the machine guns go, right here. But I have them covered up. By the way, I raced at Reno, and this was really fast. I love having this nice, fast, slick wing. But my originals will go back on here by next year. All right. Another interesting fact. The Corsair has a high camber wing. Hopefully you can understand the technical jargon. But this has a high camber wing, which is aerodynamically speaking, if you compare it to a Mustang has a laminar flow, which is a very shallow, thin wing. High speed, but very different. This has a high camber, so it lifts much, much more than, say, a P-51. So having this high camber wing allows it to handle rockets, bombs, drop tanks, and my girl's kind of heavy too. She's almost 10,000 pounds sitting here, 98 and some change empty. So the gross weight on the Corsair is 15,700 pounds. So it's a lot of armament, it's a lot of useful weight. It's all because of this high camber wing. And you can see how fat that wing is. Pitot tube, obviously airspeed, and that's a pre-flight check. I always make sure. You know, I went to an air show one time and I saw somebody, fortunately it wasn't my airplane, a young boy doing chin-ups. Thought that was a cool chin-up bar. So you have to pre-flight these items to make sure you don't have any problems with this airspeed, because that's what tells you how fast you're going. And then there's a cover that goes on top, and that cover goes on, and that's another pre-flight item that I took off earlier today, and it's really nice. The only issue with that is if I'm folding the wings, I fold the wings, get out of the airplane, get my cover, and I go, it's folded. You cannot get it. Actually, I did one time. I did climb up. You can actually, it's not recommended, but you can do it. It's just really high up there, because you can imagine. But the wings actually articulate over center. So the wings aren't like this, or more so like this. So you can kind of quasi get to it. But you need to put that tube cover on before you fold the wings. Here's your nav light. I have a strobe built in, just a little tidbit. These tips are not metal. They're actually a material, like not a Bakelite, it's like a fiberglass tip. And but a lot of people don't realize that. So that is fiberglass, not aluminum. As we go over, my other wings, which was typical for a Dash 4 Corsair, is material. This is all fabric in this section. This particular set of wings is metallized, which they had on the Dash 5 Corsair. They realized that they didn't need to save aluminum because of the war effort, and so they metallized them versus using fabric, which is very unique. Speaking of fabric, these ailerons are the hen's tooth of the aircraft. These are all wood built, structure is all wood, and then it has material, seconite fabric, that wraps the entire wood and seals it from weather, from a lot of different elements out there that would decay wood. But that's really interesting. You know, it's a 410 knot aircraft. That's my max speed, and these wooden ailerons, balanced properly, can handle 410 knots, which is, you know, well over 450 miles an hour with wooden ailerons. That's interesting. This right here is a trim tab, and so I have all axis trim adjustment. I can adjust the wings, the pitch, and the roll. In other words, the rudder. So all three axes of the aircraft I can adjust to make it nice and easy. There's an interesting shoot up here. Here's a handhold, and what you do is you go in here like this. When you're pushing the aircraft around, you grab this wing, and on the opposite side is another one, and you can control the aircraft and move that tail where you want it to go when you're trying to move the aircraft by hand. So that's a handhold that I don't know if everybody really knows about that. Another very interesting piece, this was a design that Chance Vaught added to the Corsair, and this is called a balance tab. And the purpose, if you look at this aileron and you notice if I deflect it down, it stays level. it stays in the airstream, and it acts like power steering on the stick. So as you deflect it the opposite way, it deflects and stays in the airspeed and gives you a little extra power. So, in a Mustang, I like using a Mustang. In a Mustang, the faster you go, it becomes like a truck. And it takes two hands to do aerobatics and push the stick because they don't have balance tabs. So now you have to, you have 300 knots of speed over the aileron. It takes a lot to push that aileron into the wind to make that aircraft maneuver. The Corsair, with this enhancement, it's like power steering. The faster I go, I can take two fingers and just fly the airplane, do my whole routine with two fingers because of that power steering called a balance tab. So that's an interesting design element. As you see, this is where the three machine guns, the 350 caliber machine guns go. And as you see over on the left side, each gun has two cans of ammo, and they transition. Now the machine guns are staggered, and that's what you would have seen on my other wings, is that there's one on the high end, then one in the middle, and one's short. And each of those bands of ammunition go in there, and they're staggered. So it all works with three cans of two sets of cans that go in there to supply the 50 caliber, and the brass drops out of the bottom. There's slots down there. My other wings have the slots, these don't. This is clean wing, fast wing. So the aircraft has a lot of flap area. That was one of the designs of the aircraft because they had to slow it down. This has to get very slow for this size of an aircraft to land on a carrier. But you can see there's 1, 2, 3 sections, both sides. So you have 6 sections of flaps, and they're all tied together via rods, push rods. And see, these are tied together in this area right there, and then they attach to the bottom of the wing, and then you have air guard that comes out that keeps the air going and doesn't, it's like an air gap seal. And so that flap is, we'll get into that later about it, but I just want you to see how much area is involved in these flaps. And they're sitting at the lowest or the highest degree of flaps that are available. Now, this is an interesting fact. Here's a handhold. Here's a foot. And there's nothing on the side here, but there's a handhold way up there. And here's a little step to get in the cockpit. But there's a missing link. There's no foot plate. You have no step. Can't get on the airplane on this side. Some of them, they cut them in, some of them they don't. The original aircraft did not have anything on this side. So everybody says, well, why would you even have these accent points? It's maintenance. Maintenance would jump up on the wheel and jump over on the wing walk, come over here, talk to the pilot, be able to put one foot over here, communicate to the pilot. They could have another maintenance guy on the other side, which is the way you get in the aircraft. So that's interesting that it's kind of halfway there, but it's not very functional from the ground. You have to get up on the wing and walk across. So that's kind of interesting. The wing walk, there are some airplanes that don't have the wing walk because they want to be, whatever reason, authentic, because it blocks the color of the wing, but it's not correct. You want to have wing walk that has a little bit of sand in the paint, and it gives you that grip. And I can tell you, I have fallen off this wing, and your feet go like that, you hit that wing root, and you hit the ground. Whatever your position is, you're hitting the ground. Not pretty. So I have a nice aggressive wing walk, and your feet will really stick on that, as well as getting your foot inside the step. Everything is very aggressive, works really well. We have some antennas. Some are the original antennas, like that's an original comm antenna back in its original design. That's an original antenna, it has a wire that goes back to the tail. I don't have the wire hooked up because I do a lot of aerobatics, and I'm trying to minimize things that would fail or break, and I wouldn't want a wire back there flipping on the back. So I left the post, which is showing the antenna and where the wire would go, and it goes up to the very tip of that vertical stabilizer. That's where the other side of the wire would connect. And then, well, I think it's on the other side. It goes in, the wire follows down the fuselage, goes into the radio bay. And that's for one of the radios. So as we transition back here, there is a little cover right here. It has a screw in the center, and there's one on the opposite side. And if you take this little cover off, it's a hole that goes all the way through to the other side. I have an 1 3/4 solid rod that goes all the way through the tail. And then I have a jack on this side and a jack on the other side, and that's the only way you can jack up the tail on the Corsair, especially if you're going to do a gear retract. I do my own work on the aircraft, and when I do an annual on the airplane, it all has to be jacked up. So the airplane is very high in the air. But because that engine is so heavy, if you were to jack up the tail, it could flip over on its nose. So I have to actually keep the tail down. So I have these huge weights that I have to slide 2 weights on this side, 2 weights on the other side to counteract the tendency for the nose to go down. So we keep the tail down, we jack it all up, and then I cycle the gear, which includes the tail gear, and I will take and make sure my doors are fine because I do a lot of high-speed acro. Things can loosen up. And so when you look at the gear, well, here, this is a really nice tie-down ring, but they use that on the carrier to really anchor the aircraft on the top deck of the carrier. And this little bar right here is really critical. It's called the tail hook. And that's what you're going to use to land the aircraft on the carrier. And that hook back there is what grabs the cable. Very strong, robust tail gear assembly. It locks and it just allows a certain degree. It's not a steerable tail wheel like a Mustang or some of the other aircraft. This is a free castering tail wheel in which you have to lock on every landing, so it limits do a few degrees left and a few degrees right, so it keeps you tracking right down the runway for takeoff as well as landing. Servicing, if I want to service the strut with nitrogen, I open it up. It's also an inspection cover. Gets into a lot of gears and mechanisms that are working the rudder and the ailerons. Access cover for maintenance. What's unique about the Corsair is if you notice on the rudder and the elevators, they're fabric. They did not use aluminum, and the reason being is that it's light, but also we're during the war effort. They're trying to save aluminum. But by saving aluminum, like a Mustang or some of the other aircraft, they went to that metallized control surfaces. It becomes very heavy. The fabric makes it very, very light. So having these control surfaces in fabric makes it much easier for the pilot to actuate. And as we come over here, you see what we have right here? Remember we talked about the balance tabs on the elevator, on the ailerons? Well, the elevators have the same thing, which is power steering. So all axis of the aircraft, less the rudder, yeah, it's just with your feet, doesn't really mean much. It's really that stick force because you're over here working the throttle and you got the stick, and so all axis, roll and pitch, has the power steering, so I can actually fly it with 2 fingers, where a Mustang driver has to use 2 hands, like Quicksilver. Scooter, that's why he has big muscles. He needs them. And so this, right next to it, is the trim tab. And so if I have a nose heavy, nose light, if it's high, low, I can trim it to absolute neutral by the trim tab in the cockpit. As well as the rudder. Rudder has a trim tab, and if it's pulling to one side, the ball's offset in my turn and bank, I can center it by simply a dial inside. So trim the rudder, trim the elevators, and trim the ailerons. All 3 axis trim on this aircraft. hear that. It's like a drum beat. The Indians are coming. I have different camera mounts in this aircraft, so you'll see unusual things. These I simply have a camera, and I can take and photograph, whatever, video, any aircraft flying with me. I use those a lot with Class of 45 with Scott Yoke. When he flies a Mustang, we have a routine together, and I'll put up cameras and we'll just want to video our routine. And you can see more access doors. Oh, here's the other one for lifting the aircraft tail or holding it down as I described. That's the other side, and it's a clear hole that runs all the way through the tail. And more access to servicing the aircraft. You probably didn't notice this, but on the other side it had USS Valley Forge. On this side it has USS Boxer. And everybody says, wait a minute, you got to choose one or the other. Why do you have one side with 884 VF, which is a Navy squadron, and the other side is VF 653? Why would you do such a thing? Well, let me tell you, my dad, when he researched the bureau number, which is 97143, that's the serial number of this aircraft in the Navy, he found it was on two different aircraft carriers, USS Boxer and the USS Valley Forge. He then went to the squadrons, figured out the time frame, figured out that this aircraft bureau number was in those squadrons. So then he went to the pilots and said, hey, can you look in your logbook to see if you have 97143? We found 8 pilots that actually flew it in combat. And it's in their logbooks. Yes, flew this aircraft. We did this strike on this power plant. You know, we took out this train, because this was a ground support. So they took out, they didn't do dogfights in the air with other aircraft. They were ground-based support. And so some were from 884, some were from 653. Well, the Boxer in 884 was Olathe, Kansas. And I think we had 4 pilots from that squadron that we found 4 pilots actually flew it in combat. The other side is USS Valley Forge 653. That was an Akron Canton squadron. Found out that X amount of pilots from Pittsburgh and from Cleveland flew the aircraft. And we built the aircraft, rebuilt the aircraft in Pittsburgh, because we were living in Pittsburgh at the time. We actually had a couple pilots in Pittsburgh that flew this aircraft on the, that would have been the Valley Forge. Really neat. Now, unfortunately, all the pilots have passed, but there's a crew chief from 653 that lives in Naples, Florida. He's 93 maybe now, and he's still there, and he does travel to air shows with me, because he and my father used to travel back in the 90s, air shows all over the place. And so that's why we have one side with a Boxer, the other side with a Valley Forge, because my dad couldn't decide, well, we're just going to recognize Olathe, or we're just going to recognize Akron. You know what? These guys, we found pilots that flew both of them from each squadron. We're going to recognize each one. So that's why you see 2 different names. Yes, I get a lot of people to say that's not authentic. But you know what? It's about the people. It's about the pilots that actually put their feet in the rudder pedals and they flew this thing in combat. We felt that we needed to recognize those guys. That's why we did that. So just a little tidbit. Okay. So this side is very much identical to the other side, but this side is the one we're actually going to climb on the aircraft. Telltale sign, there is the footstep in the flap that you need to get you back up to this handhold, this footstep, and if you notice there's a lower handhold here. This is will get you up on the wing step, then you transition to the upper. Then you come back over here to the step and then climb into the aircraft. So this is the side that I will enter the aircraft and exit the aircraft only. Unless I want to do a Pappy Boyington and jump off the wing in the front, which you could do, but I'm starting to get a little older. I like the steps. So what you have up here is the fuel tank. It only has one fuel tank, and the fuel tank is in this whole section right here. So basically, I'm flying behind the fuel tank. There's 234 gallons in here, and it is a completely encased fuel bladder system. Oh, look at that GoPro mount. That's kind of a cool shot to have a GoPro right up the hose nose. So as we transition, oh hey, remember this from the other side? That's the jerry strut cover that goes into that threaded hole on this side. So jerry strut right there. And then we come into the oil service. This is where I service the engine oil. And make sure you hold on to it. This dips. Oh, you know what? I'll just show you. This will be a unique one. Okay, so we have a max oil of 27 gallons, not quarts. And right now I'm sitting at 22 gallons, which is about right for my demo. I'll be flying my demo with 22 gallons of fluid, of oil. And because I run it at that level, it doesn't really exit. I do aerobatics with negative and positive G's. And when I go into the negative G's, it pushes out the vents. So if I go any higher, I'm just going to lose oil. It's going to become a dirty girl because it'll come right off the belly. I got to scrub more. I found out 22, 21 gallons is really good for my demo. When I go home, I bring it up to the high end and travel back home. This one up here is my hydraulic reservoir, and it's a 5-gallon reservoir, and it has a dipstick, and the dipstick has a hole and a rib and 3 holes, and you can see the add mark is right to here. So I want to keep it between these 2 ribs, but sometimes it's hard to see, so they give these holes, and when the holes fill up with oil, because you can't even see the oil on there, and it's very difficult, but you can see the holes. And so that's how I check my hydraulic fluid to make sure that I have hydraulics. Well, now we're in the cockpit, so let's kind of take a look at the cockpit. Some of the cockpit is standard, the way it was originally, and some of it I have modified. Because I've flied a lot, all flight critical instruments have been changed to a new instrument so that it's reliable, and if I'm flying into weather, I feel confident that everything is good. Here's the original clock. That is one of the original items. The airspeed, I changed it to a more common. The G meter is an original G meter. Manifold pressure, that's pretty common, but that's a high. If you notice, it goes up to 100 inches, although my red line is down around 60. RPM, the RPM is 2,800 maximum. And so that's all very reliable, but original. This is original equipment as well as a tach generator on the aircraft. I use some more modern equipment. These are gauges that measure cylinder head temperature, the EGT, and also fuel flow. These are good indicators for me to tell me that all 18 cylinders are making power. They could be warm, cylinder head temperature could be up there, but it's not making power. So me measuring the exhaust gas temperature, EGT, it tells me that every cylinder or which cylinder of the 18 are not giving me power. So then I can go straight to cylinder number 12 and address that problem. So it's a troubleshooting platform, but it gives me a good idea because I only have one fan spinning and I want to keep it spinning. Cylinder head temp, fuel gauge, 3-in-1, that's original 3-in-1. Navigation, my DG, coming up, horizon, original wet compass, airspeed, then we go to turn and bank, manifold pressure, which is power, RPM, there's my mag switch, and above it is my G meter. This is an original checklist, and I have it sitting on landing, and I can change it to takeoff, and it gives me a nice checklist to make sure that I have all the proper items addressed. And I leave it landing. And then as we transition over to here, we have the landing gear. Now, what's unique about this aircraft is it has a dive brake section. So you have landing gear, and when you come up, you can shift it over and come down to the dive brake side. And what that does, it keeps the tail gear in and does not allow it to be deployed. So the main landing gear will come out, and that is your dive brake. Now you can see I blocked it. Dad didn't even want us to even think about going over there by accident, pulling the gear down and only having the mains and not the tail. But that is one of the operational conditions of this aircraft. In case you needed dive brakes and you just wanted to point the nose straight at the ground, you deploy the dive brake and you can just push the nose over, and it will never exceed a max V&E speed of 410 knots. So that's interesting. Here's the arresting hook, and so sometimes I will demonstrate that. The hook operates, and when I come across the crowd, I'll put the hook down, and you'll see the hook down as I come across with my dirty pass. Another interesting is the wing flaps. You can see there's 0, 10, 20, 30, 40, and 50. That is incredible, having 50 degrees of flaps. If you notice, there was a lot of flap area out there on the flaps, but more so 50 degrees. And you needed that because of the hose nose. If you look down this nose, you can see how long that nose is. You see that aircraft carrier we're about to land on? No, you'll never see anything forward. So the 50 degrees flaps pushes the nose over to allow our AOA, remember we talked about AOA, so your angle of attack can be lowered and not block all your forward vision. So that's the reason for the 50 degrees. It slows it down. My stall speed on this aircraft is 77 knots. So I have to stay north of 77 because it'll fall out of the sky at 77 or thereabouts. So, but only can I get there by 50 degrees of flaps. Typically pilots are coming in 4 knots above stall. So you're looking at 81. And that nose, it would be super, super high if it wasn't for the 50 degrees of flaps. And they couldn't see it. So there was a technique that they learned, and it was a pitch down, watch the LSO officer come down on the neck and slam it. That was the technique because the nose is so long to land this aircraft on aircraft carriers. So there we go on the flaps. Here's my landing gear indicators so I can see that both my mains are down. And also this is my tail wheel. So I know that all my gear are down and locked with those indicators, and they're tied physically with a cable to each of the 3 landing gear. Here's my fuel pump. I have emergency and I have boost. So it's a 2-stage pump. So in case one fails, I still have a backup. Fuel transfer, if I have a left drop tank, I can go to my left drop tank over there, or I can bring it over to my right. And what that does, it actuates an electric pump, and it transfers from the drop tank to my main tank. So everything is transferable. That doesn't mean that I could fly off the drop, but guess what? I can fly off that drop tank if that transfer pump fails. By right here. Right now it's on the main tank, but see right here, right drop tank standby. So I could flip this over to the right. It will draw the fuel from the right drop tank straight to the engine. Not to my main tank, but to the engine. The only problem is we have no idea how much fuel is in that drop. So when it is done, you will know it because the engine will stop. It's time to flip it. And you could do the same thing for the left. So you can still get the fuel out of the tank, it's just in a different way. Another redundant way of getting fuel out of those drop tanks. Here's your quadrant.
Bug crawling my leg.
Oh yeah, there's a bunch.
Okay, good.
Here's the throttle quadrant, and so what you have is your power. This is manifold, but this is fuel going to the engine, throttle. This one is a propeller, so this controls the RPM of the engine. And this is my mixture control, and so we control the mixture, in which it's the air-fuel ratio mixture going to the engine. And as I said, that's your fuel, and we can turn it to off, and then we lock the fuel out so it's not going anywhere. You know what I forgot underneath here? Here's your cowl flaps. And so you can take your cowl flaps and open them by pushing it this way, or you can close them by pushing it this way. So that's the cowl flaps. That's right over there. See, you can see those from back here. You don't need an indicator. You can just look at them. And so this is a trim. This is my aileron trim. And this would be, right here is my elevator trim. And this is my rudder. So rudder, aileron, elevator, aileron. So roll, my pitch, and this is my yaw with the rudder. So you have 3-axis trim on this aircraft. And also, here's the supercharger. So I can be a neutral blower, and I can come up to low blow, or I can come all the way up to high blow. In this particular aircraft, I don't utilize this. I have a switch that's electrically actuated to go into high blower or low blow. But that's part of the original quadrant and an engine that I don't have in this airplane. But that's the actual mechanism to shift it from high blow to low blow. Here's the wing fold mechanism, and it's a very interesting design. It is hydraulically actuated, so I'm in the spread configuration. I can bring it up to neutral, be like a center lock, or I can fold them. So what I have to do is unlock this physical pin. This pin is on a spring-loaded cable. And if you look out in the wing, see that little tab that comes up? That's how I am actually putting a pin into the hydraulic cylinder to ensure it will never back out. If the wings were folded, I could show you that lock mechanism, but when the wing is folded, spread, there are holes. It's kind of like an eye and a clevis coming together, and there's a hole through all of it. And there's a pin on the cylinder that goes through the clevis and the eye that locks the wing down. So hydraulic pressure, if it were to fail, you could have it slip out. Well, by actuating that pin, it goes in the back of the cylinder and locks that cylinder so it stays engaged and can never back out of the wing. So when I'm flying in flight, I can be ensured that cylinder will never back out and my wings will always be locked in the spread. So I'm going to go ahead and lock that pin, and when I do this, it locks it down. So that's one of my pre-flight items. I look on both wings to make sure both of those tabs are down so that my wings stay in the position I want. Back here, if I were to have drop tanks, I can deploy my right drop tank by using this lever, or I can deploy the left pylon. So whatever I have on the pylon, if it's a drop, if it's ordnance, this is how I would drop a bomb. So normally they would take the left pylon, drop their bomb, 500-pound, Tiny Tim, whatever the ordnance is. That's how you would drop it off the aircraft. That's how I drop my drop tank. If I put a right one on, which I have, and I want to take it off the airplane, I have a couple of guys down there catching the drop tank, and this is where I pop it, and it'll release it. So that's the pylon releases. And just forward of that is my tail wheel lock, and this locks my tail wheel. So right now it would be locked in that very limited left and right position, or I can release it and it's a full 360-degree swivel. This aircraft has oxygen on board, and so here's my valves for opening and closing my oxygen bottle, because when I fly the airplane, I'm on oxygen the entire time. Interesting fact, see down there? It says dump the tank pressure. What you can do is you can take that and turn it on. It pressurizes the fuel tank. This aircraft has a service ceiling of 41,000 feet, and fuel is not intended to be consumed at 41,000 feet. So fuel tends to get a little crazy up there. So we pressurize the tank, and it allows the fuel to stay in its condition that it's expected to be flowed through the engine and run correctly. If you don't pressurize the tank, you'll actually not be able to use the fuel. It reacts in some very bad ways. So that's a pressurized, but that's only for high altitude, which I don't go up there anymore, so I just leave it in a dump state, which is just natural state. On this side is my switch panels. Over here I have my battery, my primer, my starter, and my pre-oil. And I go through my sequence of starting. Got a radio master, external lights, pitot heat, strobes, section lights, navigation lights. Remember we talked about that approach light? I can actually turn it on, and it does function and work. So those are the switches I use. I have a hydraulic auxiliary pump, so I can actually fold the wings on the ground by using that pump. So these are things I added for convenience purposes. Come down here, here's your lights. Here's all your circuit breakers for the aircraft and all the electrical systems. And here's my radio. So I have an audio panel here. I have COM 1, COM 2, nav. My nav does have ILS, so I could shoot an approach. And then I have my transponder. Now this is really cool. Not very many airplanes have this. I have an onboard camera system, and this records all my cameras. And I have cameras on each side of the cockpit, so I can take video going off my wing this way, off my wing that way. I have a camera that's on the side of my helmet here that faces right out the screen, which is a cool shot. I have another camera right here that faces me, and when I'm upside down, I can get some pretty cool shots out of all this glass canopy. And but that's an onboard camera system that I can utilize as well. Oh, here's an interesting fact. That's a lock. That lock is supposed to be on for takeoffs and landings. That way the canopy can never come forward. It's an emergency situation where if I were to have an accident and the canopy could run all the way forward, break all the mechanisms, and lock me inside the canopy. Well, with this right there, that ensures the canopy will never come forward. And so for all landings and takeoffs, that's something that it was always flipped over. And also, when I'm inside, if I have to have an emergency, I have a red handle here, and I pop it, and the canopy comes off, so I can exit the aircraft. This is the weapon system on the aircraft, and these control all the different, these are armament. You can see these are bombs right here, salvos. You could go in groups. You can release rockets individually, collectively. You can use one in the right, one in the left to make opposings. All different things. You have a gun sight. I actually have the original gun sight that goes in here, and it's operational. Then you can have guns. You can have just the inboard guns. You can have the center guns, the outboard guns. Now remember, they always go in pairs. So if you do outboard, you get outboard left and right. So you could turn all of the guns on and fire them all at one time. Pilots say when you do that, you can actually feel the airplane backing up with 650 caliber guns going off. So they usually use them individually, plus saving rounds. You don't want all 6 going out there. And I forget it was, every 5th round was a tracer. So you can see the tracer and you know where your rounds are going, but you want to be selective. Only have 2,400 rounds. So then you have master armaments, but this is your weapon systems, and this is what actuates, and this is what they originally looked like. Your gun sight has a rectal coming up, and you can make it as bright or as dim as you want so that you can see your target, which is lined up with the machine guns. So now the center pedestal has charging, and so we charge the 50 calibers. So the guns on the right side will be charged hydraulically. So basically this is just taking hydraulic pressure, shooting them to the guns, charging the guns for operation. They need hydraulic pressure to shoot, and then when you unload them, you come back to the safe. So when you land on the boat or come back to the base, they're non-operational in the safe mode. So you got left guns and right guns. You got the oil cooler door. Remember we saw the oil cooler? I have doors, I forgot to show you that I can open and close based on my temperatures. And then also I have oil cooler door location, so I can actually open them, which is always open, always closed, because this engine runs really cool. But if I want to open it, I can sit down and open this thing all the way up. But the engine runs so cool, very seldom. And it's in its automatic position, so when it comes up here and the oil temperature gets in that yellow range, I'll start to see this door open. It opens on demand, so as I get hotter of oil temperature, it will start opening further and further, so I can look down here and know that it's operating correctly. My intercooler, remember I said that I didn't have it. This actually would control the intercooler and the flaps. Here's your oil shutoff. Remember I mentioned that if I had problems and the one oil cooler was shot up, I can pull this and turn it and isolate the left hand, or I can isolate the right hand oil cooler, and it won't keep dumping oil overboard. There's my emergency bottle. I have a blowdown for my emergency gear extend, and so that's my bottle. It says I'm right up to high temp. This is my fresh air. This is my bestest friend in the whole wide world in hot temps. And hydraulic pressure. I'm always right around 1,000 psi in operation. And down here is how I extend the gear with the emergency. If I lose hydraulics and I have to use the blowdown bottle, that's my procedure. Well, that's it. I think hopefully I've educated you a little bit on the Corsair. It's a great flying airplane. Way better than the Mustang. Yeah, you can tell Scooter, it's Quicksilver, Mustang versus Corsair. Corsair will get them every time. But thank you for joining me. I hope we educate you a little bit on the Corsair, and hope to see you around sometime.